Okay, to start off with, we're going to do a quick review of how do we find the measure of an angle. So remember, we need to make sure that we have the right buttons on our calculators. So over here, this screen right here is off of my TI, my graphing calculator. And remember, you are looking for the inverse button, which is the buttons above the sine, cosine, and tangent button. And then the other thing that you want to make sure is that you're in the correct mode. So on the TI-84 graphing calculator, there's a button that says mode, and then this screen comes up, and you can see right now that I'm not in degree mode, and I would want to switch it to degree mode so that this is highlighted. So I'm going to go ahead and do that, make sure my mode's in the correct, or my calculator's in the correct mode. And now I'm going to figure out what this angle is. So to do that, I'm going to be standing here, and it's right triangle trig, so I'm going to use one of my sine, cosine, tangent buttons. So if you're at theta, this is considered the opposite side, and this is considered the adjacent side. So it looks like to me I'm going to want to use tangent theta. So tangent theta equals opposite 10 divided by adjacent. So remember, we're looking for an angle, so we need to use the inverse button. So to write that, I'm going to write inverse tangent, and then I'm going to switch the sides and the angles. So 10 divided by 8 equals theta. And then I'm just going to type this in my calculator using the inverse button. So I'm going to use inverse tangent button on my calculator. So inverse tangent divided by, and then I'm going to put 10 divided by 8. And oops, I forgot to change. I said I was changing to out of radian modes, and I forgot. Let me quickly change that out of radian mode to degrees. Okay, I'm in degree mode. Um, Inverse tangent of 10 divided by 8 is 51.3 degrees. So that angle measure is 51.3 degrees. Okay, in this particular scenario, my theta is in the upper right-hand corner of the triangle, so this is now considered the opposite side. This is considered the hypotenuse. So the trig function I'm going to use then is going to be sine. So I'm going to say sine theta equals opposite over hypotenuse. And since I'm looking for an angle measure and not the ratio of sides, I'm going to do inverse sine. So inverse sine of 7 divided by 12 equals theta. I'm going to go to my calculator. Inverse sine of 7 divided by 12 is 35.7 degrees. So this angle measure right here is 35.7 degrees. And this triangle, theta is down here in the lower right-hand corner. So if I'm at the lower right-hand corner, this is considered the adjacent side. This is considered the hypotenuse. The trig function that uses adjacent and hypotenuse is cosine. So I would write cosine theta equals adjacent over hypotenuse. And since I want to find out what theta is, I use the inverse button. So inverse cosine of 12 divided by 13 equals theta. Type that in your calculator, inverse cosine of 12 divided by 13, and theta is 22.6 degrees. So 22.6 degrees. Okay, on this slide right here, it wants us to find sine A and sine B. So if you're standing at A, sine is opposite over hypotenuse. So sine A is 20 over 25. You're going to want to reduce any fractions, so that's going to reduce by 5, and that's going to turn out to be 4/5. Okay, we've been writing our ratio sides as fractions, but you can go ahead, and you'll see this a lot on the ACT testing. They won't write it as 4/5. They'll actually write out its decimal value. I don't know if you remember last lesson when we did all those calculator issues and we went to 4 decimal places. That's what they were doing. They were taking and they were doing the ratio of sides to a decimal. So if you take 4 and divide it by 5, you end up with 0.8. So you could write it as 4/5 or 0.8. And then sine B So I'm going to switch. So sine B is actually opposite over hypotenuse. So that's 15 over 25. And if you reduce that by 5, you end up with 3/5. And same thing, if you wanted to write that as a decimal, 3 divided by 5 is 0.6. Usually they go to 4 decimal places, but that terminates at 0.6. Okay, and the other thing that I haven't really highlighted, but I noticed, when I looked at this triangle, the first thing I noticed was that they were all divisible, all the sides were divisible by 5. If you did that at the beginning, so if I divided this by 5, that would give me 3. 20 divided by 5 is 4, and 25 divided by 5 is 5. Notice when you do sine of A now, you end up with the opposite side of 4 over 5. It gives you the reduced ratio. So you either have to reduce at the beginning or the end. Sometimes it just gives you smaller numbers to reduce at the beginning. So that's okay to do. If everything is divisible by the same number, you could go ahead and reduce all of those sides. So sine B turns out to be 3/5. So basically what happened was that this was a multiple of our 3, 4, 5 Pythagorean triple. Okay, this triangle right here, I'm looking 8, 15, 17. Those don't reduce, so I guess I'm just going to go ahead and answer the questions. So if I'm standing at A, cosine of A is the adjacent side, which is 8, divided by the hypotenuse, which is 17. And I'm going to go ahead and write that as a decimal, the 8 divided by 17, just so I can see what its ratio is divided out. So that would turn out to be 0.4706, 4 decimal places. So you could see cosine A is either 8 over 17, or they could say cosine A equals 0.4706 and divide that ratio out. Okay, cosine B is adjacent side over opposite, or excuse me, adjacent over hypotenuse. And we can leave it like that, or we could go ahead and divide that out. So 15 divided by 17 as a decimal is 0.8824. So you could write it either way. All right. Now we're going to go over angle of elevation and angle of depression. So when we draw our application problems, our word problems, and we want to draw our pictures, we kind of need to know what angle of elevation means and angle of depression. So just the word in and of itself, angle of elevation, kind of means to elevate or to look up. And it says when you look up at an object, that angle of your line of sight, that's what it is. Wait, I didn't read that right. When you look up at an object, the angle that your line of sight makes with a line drawn horizontally, that's what an angle of elevation is. And an angle of depression is when you're looking down, when you're from a horizontal. So what that means is, so this little boy down here is standing on the ground, and he looks up at the little girl. So he looks up at the little girl. This is the line of sight. This is considered an angle of elevation, what we made, okay? But the little girl happens to be looking down at the little boy. So she is looking down. So she looks out from a horizontal. Then she looks down to see the little boy. This is her line of sight. So the angle of depression is this angle up in here. So basically what happens is that an angle of elevation and an angle of depression are equal. I don't know if you remember back last year when you guys studied alternating interior angles. This is an angle of depression. And it is the same thing as this angle down here, because this is an angle of elevation. They're alternating interior angles. Most students get angle of elevation correct. They have a harder time figuring out where the angle of depression goes. So if you're not sure where your angle of depression goes, just use it as an angle of elevation. If somebody's looking up, somebody else is looking down along that same line of sight. Okay, so here it's just a picture with a bunch of objects, and you just have to decide, is it an angle of elevation or angle of depression? So this seagull is flying around, and it looks out, and then it looks down to see somebody in the lighthouse. Okay, so that looks like an angle of depression. Okay, but somebody in that lighthouse happens to be looking out, and then they look up at the same angle and see the seagull. So that's an angle of elevation. Okay, well, that same person in the lighthouse happens to look down to see the boat. Okay, so that's an angle of depression. And then there's somebody in the boat who happens to look up and see somebody in the lighthouse. So that's an angle of elevation. So are you looking up or looking down? But both of you are looking at the same spot. So basically, if you could like make this a laser line or something from coming out of your eyeballs, that line would be the same. Your line of sight is exactly the same. Okay, here's my fun pictures. Use your imagination. So there's this person up here in the house, and he looks down. So he looks out his window, and then he looks down. Here's his line of sight, because you look out and then you look down. You always look out and then down or up at that dog down there. I guess that's a dog, some kind of animal down there. And we want to know at what angle does he look at? Well, okay, so we're looking for theta. Well, this is considered the opposite side over here, the 20, and the 30 is the hypotenuse. So I would do a trig function, which would be sine. So I would say sine x equals opposite over hypotenuse. So remember, if you're looking for an angle, you have to do the inverse button. So inverse sine of 20 divided by 30 will give you angle x. So inverse sine 20 divided by 30, and it turns out to be 41.8 degrees. So that angle is 41.8 degrees. Okay, another fun picture. Somebody's flying a kite, and this is the angle of elevation of this person looking out. So they look out, and then they look up to see their kite. So this is their line of sight right here. And we want to know from their line of sight, how high up is the kite? Well, so I guess I'm going to pick a trig function. So once again, this looks like the opposite side. This looks like the hypotenuse. Let's give this some units. We'll say this is 100 feet, just so we can maybe know what's going on here. Okay, and this is our hypotenuse. So we're going to say the sine of 63 degrees equals the opposite side over the hypotenuse. And then I'm going to solve this for x, so I'm going to multiply both sides by 100, and we're going to have sine 100 times the sine of 63 degrees equals x. So I'll just go to my calculator, 100 times the sine of 63, and that turns out to be 89.1 feet. So this right here would be 89.1 feet. Okay, so sometimes they like to ask, so a lot of times they make the assumption that your line of sight is on the ground, and they kind of disregard how tall the person is standing. They'll say like, oh, you're standing on the ground and you look up, and they kind of just assume that everything is just at that point. We don't take into account how tall somebody is. But if you did have to take that into account, so if the question said something like, um, how high off the ground is the kite in the vertical direction, what you would need to know is how high this person, this kid, is holding the kite string above the ground. So let's just say this is 4 feet off the ground. So then all you would have to do is add 4 feet. And so instead of 89.1 feet, the answer would now be 93.1 feet off the ground. So sometimes they make the assumption that there is no difference between the ground and the person looking up or looking down, and you kind of just have to read into the question. Sometimes you just have to make some assumptions. Okay, so this one right here, it says a lifeguard is watching a beach from a line of sight 6 feet above the ground. He sees a swimmer at an angle of depression of 8 degrees. How far away from the tower is the swimmer? Okay, so here's the line of sight right here where this lifeguard is. So right here, so we're going to say this is the ground. Here's the swimmer over here in the water off the beach. They said this is 6 feet. This distance right here is 6 feet. We're going to say that's perpendicular. Okay, and then it says the lifeguard sees the swimmer at an angle of depression of 8 degrees. So remember, when you're doing an angle of depression or elevation, you always look straight out, and then you look down. So he looks down and sees the swimmer. So the question is, where does the 8 degrees go? Well, remember, an angle of depression is the same thing as an angle of elevation. So if the angle of depression is 8 degrees, then that must mean the swimmer is looking up at an angle of elevation of 8 degrees. So swimmer is looking up at 8 degrees, lifeguard is looking down at 8 degrees. A lot of times your angle of depression may not be drawn inside your triangle. Kind of depends on how you draw that. Okay, and it says how far away from the tower is the swimmer? So we're going to look for this ground distance right here. So if you were standing at 8 degrees, you would use opposite side over adjacent side. So the tangent of 8 degrees equals opposite over adjacent. So to do the algebra on this, I'd multiply both sides by x, and then I would divide by the tangent of 8 degrees. So I would say x equals 6 divided by the tangent of 8 degrees. So go to my calculator. 6 divided by the tangent of 8. And we end up with 42.7 feet. So the swimmer is 42.7 feet away from the lifeguard. Okay, once again, here's my fun dog. A dog is looking at the squirrel in the top of the tree. So right here's the squirrel. These are his eyeballs right there. In case you're wondering what that is, those are his eyeballs. So all you can see are the eyeballs of the squirrel looking out. So a dog is looking at a squirrel at the top of the tree, and the distance between the two animals is 55 feet. Okay, so between the two animals, I'm going to use that as the line of sight. So the difference between them is 55 feet. And the angle of elevation is 64 degrees. Okay, so the dog is the person or the animal, I guess, that's looking up. So angle of elevation means the dog is looking up at the squirrel. So this is the angle that's 64 degrees. How high is the squirrel, and how far is the dog from the base of the tree? So here's the base of the tree. Here's how high the squirrel is. So we'll just go ahead and do two different trig functions. So I think I'll do how high the squirrel is first. So that's going to be sine theta. So I would say sine theta, so sine of 64 degrees equals opposite over hypotenuse. And then I would just solve that, multiply both sides by 55. So the sine of 64 degrees times 55 will equal y. So 55 times the sine of 64. So y equals 49.4 feet. Pretty tall tree. And then I'm going to do how far is the dog from the base of the tree. So see, like in this example, we're just kind of assuming that the dog in the eyeballs and the height of the dog are all on the ground. We're kind of disregarding all of that. We're just assuming it's just a point on the ground. So then we're going to say cosine of 64 degrees equals adjacent over hypotenuse. And I'm going to solve that for x by multiplying both sides by 55. And so 55 times the cosine of x, which is 64, sorry, I said that wrong. 55 times the cosine of 64 will give me x. And so x is 24.1 feet. So the dog is 24.1 feet from the base of the tree. Okay, this one says a jet is flying at an altitude of 30,000 feet. An air traffic controller measures the angle of elevation to the plane to be 16.5 degrees. Okay, so in this one, we're just going to assume the air traffic controller and ground are all one spot. So over here, I'm going to say this is my air traffic controller guy. And let's draw ground. So here's the ground. And then here we go up to the plane. It says the plane is flying at an altitude of 30,000 feet, so that's how high the plane is right now. And that's a right angle. And somebody down here in the air traffic controller looks up, so they look up to see the airplane. And they look up at 16.5 degrees. So the question is, find the horizontal distance of the plane from the airport. So we're looking for that distance right there. So if I were to set that up, I would say the tangent of 16.5 degrees equals the opposite side, 30,000, over the adjacent side. And so algebra on this, I've multiplied both sides by x. And then I would divide by the tangent of 16.5. So x equals 30,000 feet divided by the tangent of 16.5 degrees. So that turns out to be 30,000 divided by the tangent of 16.5. And I end up with 101,278.3 feet. Now, I think there's 5,280 feet in a mile. So if we divide that by 5,280, that's about 19.1 miles. That's about how far away. Not sure if you could see that. Maybe you could, if it was big enough. Okay. Here's another one. At a point on the ground 50 feet from the foot of a tree. So let's just draw a tree in here somewhere. Here's my tree. So on a point that's 50 feet from the foot of the tree. So here's my point. I'm 50 feet from the base of the tree. The angle of elevation to the top of the tree is 53 degrees. So I'm looking up to the top of the tree. And that's 53 degrees. Find the height of the tree. So I'll call that x. So I think I'll use tangent again. So tangent of 53 degrees equals opposite over adjacent. And so the algebra on this, I would just multiply both sides by 50. So the tangent of 53 degrees equals 50 times the tangent of 53 equals x. So 50 tangent of 53 degrees. Type that in my calculator, and I end up with x equal to 66.4 feet. So you guys are going to get really good at this right triangle trig, and a lot of you are just going to be like, oh yeah, that's tangent. I'm just going to type this in, and I know how to do that, which is great, and I expect that you were going to get to that point, but I need to see what the original setup is. So in all of your homework, you always have to write what the original trig function is, what the original trig function setup is. If you want to go from that to the answer, I'm okay with that, but I'm not okay with just writing the answer. I need to see the original trig setup. So I need to know how you set the problem up. And then if you just type it all in your calculator and give me an answer, that's fine. You don't have to show the middle step. But you always have to show the full original setup to get full credit besides your answer. Okay, one more. So from the top of a lighthouse, 210 feet high, the angle of depression to a boat is 27 degrees. Find the distance from the boat to the foot of the lighthouse. The lighthouse was built at sea level. So basically what they're saying is, here's the ocean here. Here's all our waves. Okay. The lighthouse starts on the ground. So here's your lighthouse. Yeah, there's my lighthouse. Okay. We'll just show light. Light coming from the lighthouse. Okay. And then there's a boat over here. There's my fancy boat. And it says from the top of a lighthouse that's 210 feet high. So this lighthouse is 210 feet. The angle of depression to a boat is 27 degrees. So remember, if you don't know how to do an angle of depression, just remember somebody in the boat is looking up at an angle of elevation. So if somebody in the boat is looking up at the top of the lighthouse, just like somebody is looking out and down. So this angle of elevation would be the same as this angle of depression. That does the 27 degrees, if I draw it as an angle of depression, doesn't turn out to be in my triangle. So if I move it to an angle of elevation, it is in my triangle. And now I can pick a trig function to find out the distance the boat is from the foot of the lighthouse. So I think I'll do tangent. So tangent of 27 degrees equals opposite over adjacent. Algebra on that, x turns out to be 210 degrees, or excuse me, 210 feet divided by the tangent of 27 degrees. So x equals 210 divided by the tangent of 27. And we end up with 412.1 feet. So the boat's 412.1 feet from the base of the lighthouse. Okay.